So, hello everyone. My screen is visible to you. So, can you see my screen? Yeah, okay. So, welcome to the optical fiber lab, the theoretical part of the lab session we are going to discuss. So, actually, I've given you some of the problems, and now we are going to discuss all those problems. So, the first problem which I have given you as an assignment was in the last class. So, I'll write here the question which I have given you. So, the first problem was the spherical. Let me actually, it is not working. So let me make it in a clear way. Okay, so let's move to the first problem which I've given you. So I'll write the question first. So the question was like this that the spherical volume charge is given by rho v is given as rho v naught 1 minus r square by a square, and this was the first equation which is r less than a, and second was 0 when r was greater than a. So and they are asking you to calculate the total charge q. So question was like that: calculate the total charge q. So some of you are having doubt, and some of you has WhatsApp me that they are unable to solve this problem. So I have given the theoretical aspect of this question, how to deal with this and how to move forward. So if you are having any kind of doubt, I'll tell you. So since we have done for a spherical volume charge, how to calculate the charge. So charge is given as integration of the volume, which is given as the integration of the volume into dv. So that will be equal to, so if I'll open this bracket, so what I will get here, I'll get here rho v into r square sine theta dr d theta d phi. So this is the, so since I had just applied the formula for the spherical volume, how to calculate the charge for a spherical volume. So I had applied this formula, and after this I had opened the integration. So inside that I have written the spherical volume charge into, so since we have used r square, so I have put a dr, we have used d theta, I have used d theta, and we have used phi, so I have used d phi. So and we have to put the limit. So now the limit will, so for the spherical coordination, so basically this is for the spherical coordinate, and this is used for the calculation of volume integration. So I'll put the limit. The first limit will be 5 to 0 2 pi, and 0 to pi, other one is 0 to a. So I'll write here 0 rho 0 1 minus r square by a square into r square sine theta dr d theta d phi. So that is what we have to do. So after this step, most of the things is clear to us. So now what we have done, so if y I have put a limit from theta equal to 0 to 2 pi, so for this I can write here. So for spherical coordinate, what we are going to do, so for spherical coordinates, theta will vary from 0 to 2 pi. Sorry, 0 to pi. So theta will always vary from 0 to pi in case of spherical coordinate, and phi will vary from 0 to 2 pi. So only you have to remember this thing, that if you are dealing with the spherical coordinates, in that theta will always vary from 0 to pi and phi will vary from 0 to 2 pi. So this will be the case for a spherical coordinates, and what I have done, I have just integrated this and I have applied the formula. So let me open the bracket. So I think this is up to this clarity is there. So now what we are going to do, so let me open the bracket. So after opening the bracket, what I will get here, rho 0 into 0 to 2 pi. So this will become 1. So after integrating, what it will become? It will become 1. So I'll put here 1. So I'll write here minus cos theta. This will be 0 to r, and this will be r cube minus 3 by r to the power 5 by 5a square, and this limit will be from 0 to a. So I have just opened this bracket, and after this I have integrated, so I have got here r cube minus upon 3 minus r to the pi 5 upon 5a square. So let me open this more. So what I'm getting here, rho v0 into 2 pi into 2, and this will be, so since the limit is varying from 0 to a, so what I will write here, a cube upon 3 minus a cube by 5. So I have replaced the r with a and everything is same. So after opening this limit, what I will get here, 4 pi rho v0 upon, so if you open this, the LCM will be 15, so that will be 5a cube minus 3a cube, that will be 2 into a cube. So after solving this, what I'm getting here, so 8 pi 4 into 2, 8 pi upon 15 rho v into a cube. So this was our final answer. So what I have done, I have just integrated this. So I have not nothing more is involved here, so only basic integration I have used here. So based on that, I have solved those. So for spherical coordinates, you have to just remember this, that theta will be varying from 0 to pi and phi should vary from 0 to 2 pi. So is there any doubt regarding this? So are you getting this, how I have done? Okay. Okay, no doubt. So let me so I'll moving to the second problem which I've given to you. So let me move to the second problem. So if you're having any doubt, you can write in the comment section. I can see from there. So second question is, the second problem which I've given you is the volume charge density, that rho v is given as rho naught e, and it was given as mod x, mod y, mod z, and overall, and it is exits over all free space. So actually this type of problem is coming into our RTU paper. So if you're getting clarity, you will solve there also. And what they are asking you to calculate the total charge present. So how to calculate the total charge present? So is this problem clear to you? Can you see that? Okay. So actually it was given as, so since in the question only they are representing it as the volume charge density. So what we have to do, we have to just see the problem, what they are representing. So the last problem was they were considering the spherical charge density. Now in this problem, what they're asking you to calculate the total charge present, and the case which was given to us was volume charge density. So question is clear to you? Are you getting? Uh, is there any problem in reading the questions, or are you see, the first step is, if we can see the problem, if we can understand the problem, then it will be very easy for us to solve. If you are not understanding the problem, then that will not make any impact to you. So if you are getting the problem, then it is fine. So what I'll write here, I can write here, so actually we know that rho v is given as rho naught e into mod x, mod y, and z. So rho v is given as like that, and we know that how to calculate the charge. The charge will be given as q equal to rho v into dv. So this is the formula for calculation of charge. So it is the same formula which we have applied in the last problem, and in this problem also we are applying the same formula, because formula will not change. So now what I have to do, so since it is volume charge density, so I have to open this. So let me open it. So I'll write here, so now our limit will be minus infinity to infinity, because it is a volume charge density. If they are asking you to calculate for spherical charge density, then we will apply other limit for phi and for 0. So I'll write here rho naught e x minus y minus z, and since three terms are there, so I'll write here dx, dy, and dz. So and since in the problem also they have given us free space, so if they are marking as a free space, so I'll write here, if they are telling you that it is occurring in the free space, then it will vary from minus infinity to infinity. So I had used this limit minus infinity to infinity, minus infinity to infinity, minus infinity to infinity, all in all these cases. So now just simple mathematics is there, we have to apply simple mathematics here. So I'll write here minus infinity to infinity, and that will be other will be also minus infinity to infinity. The third will be also minus infinity to infinity, and I'll write here rho x into mod x e mod y e mod z. I'll write here dx dy dz. So now we have to open the bracket, so that we can do it in a very simple pretty way. So now how to open this bracket, you can see here. So I'll write here. So if you have to do simple integration, so rho into 0 to infinity 2e, the integration will become 2e to the power x dx. Other integration will become 0 to infinite 2e minus y dy plus 0 to infinity 2e minus z dz. So the integration will be this. So after opening the bracket, what I'm getting here, 8 rho naught into e to the power minus x upon minus 1, limit will be 0 to infinite, into e to the power minus y upon minus 1, limit will be 0 to infinite, e to the power minus z upon minus 1, limit will be 0 to infinite. So if you'll do if you'll open the limit, put infinite there, what I'll get here, 8 rho naught into 0 plus 1, 0 plus 1 and 0 plus 1. So theta will be equal to, anything will multiply with 1, it will be 1 only, so theta will be equal to 8 rho naught. So this is also a simple problem, and in this question the volume charge density is given to you, and based on that you have to calculate the total charge present. So the first two line only represent the electronics part, and rest of the line you have to just apply the basic mathematics formula. So if you're clear with those things, nothing will bother you in future also, and in RTO paper also. Whenever you are going to deal with the RTO paper, try to solve those questions like this. So one more question I've given to you as an assignment, so let me solve those questions also. So let me see that question also. So one more question was given as, so let me write the question first. So question was like this: find the total charge contained in cylindrical volume defined by rho greater than less than equal to 2, and it is varying as like this, and the question for rho v is given as, so this was your problem. So actually basically this is the radius of cylinder, if you can see, if you are not aware of this. So this is the radius of cylinder, this is the length of cylinder, and this is the volume charge for a cylinder, volume charge. So let me draw the figure, then there will be more clarity. So I'll write, so length will be decided like this, so it will be z, and this will, so cylinder will be, and this is 3. So I had already show you how to draw these things, so I think that will be not any bothering part. This is 0, this is 2. As you have to calculate the angle, then you have to see x and y axis. So this is basically y axis, this is, and for angle this is phi. So actually this is phi. So this is our question. So and they are asking you to calculate the total charge. So basically they are asking you to they are asking you how we will calculate the value for q, and since it is cylinder, then radius is also given to you, length is also given to you, and volume charge, all those three things are already given to you. So is the problem is clear to you? Problem is, are you having any kind of doubt in seeing the question? Okay, so actually this is rho, this is varying from 0 to 3, this is rho v, that is okay, fine. So problem is clear to you. So now let me move to the solution part. So what we are going to do. So since they are asking you to calculate the total charge, so for calculation of total charge, what we will do, that Q should be equal to rho v into dv. So So for a cylinder we have to apply we have to multiply extra row. So I'll write here, so we'll put the limit like this, and I'll write here row v, and since it is cylinder, so I have to apply an extra row, so I'll write here extra row, and after this I'll write here d row, d phi, dz. So since it is cylinder, then in this case we have to apply an extra row here. So I can write here what I can write here. So I'll put the limit. So height is from 0 to 3, and it is varying from 0 to 2 pi. This is varying from 0 to 2, that is z naught into rho z into 10 to the power minus 3 into rho into d rho d phi dz. So see, just you have to remember one thing, that if you are dealing with the cylinder part, for cylinder part we have to multiply an extra row, that we have already done, and after that we just needed to apply the formula. Whatever formula we have learned, we have to apply that. So since all the variables are, I can write here, all the variables are independent and in multiplication, and all the variables are independent and in multiplication. So for that, what we have to do? So see, if they are asking you to calculate for a total charge in a cylinder, those three things you have to remember this. So the radius should be given, length should be given, volume charge should be given, and after this, one more thing we have to remember this, that in the case of cylinder we have to apply extra row here. So now I have to just apply the whatever we have got here. I'll just open this bracket. So now after this, more clarity will be there. So let me open this, so I can write here. So this will be 20 into 10 to the power minus 3 into 8 by 3 into 2 pi into 9 by 2. So see, so what I have done here, so rho z given as 9 10 to the power 8 by 8, I have applied here. Whatever value I have given to us, that I have written there. So based on this, if you will put all those values in your calculator, you will get value for 1.5072 coulomb. So this is for the total charge contained in a cylindrical volume. So we have seen spherical also, we have seen volume integration also, and we have seen the cylindrical volume also. All those things we have already seen. So I hope these things are clear to you. So in the last session also I have shown you how to calculate all those things based on the formula, and in this session also I have shown you how to get all those values. So is this clear to you? So okay, so I have told you, so this is the formula for calculation for the charge in case of cylinder. So I'll write here calculation of charge in case of cylinder. So is this question okay? And if you put in the calculator, you will get this value. So I think this is clear. Things are clear. So is there any doubt in this, how to calculate the charge for a case of cylinder? Are you facing any difficulties now? I think more clarity is there, because since we have not solved any problem, I have given you the problem as an assignment. So many of you are facing some difficulties. So I've told you I'll discuss it in the class. So now, okay, no doubt. So let me move to the last part, and after covering the last part, we will close the class. So one more question which we have left with us. So let me move to that. So total 4 problem I needed to discuss. I have told you. So in this problem, length was given as 10 kilometer, which was already in your question paper, and data rate was 20 Mbps. And source power, that is PS, is given as 0.1 megawatt, and that milliwatt, that is 0. This I can write here. So basically that is 10 to the power minus 5 watt. And so if I'll calculate in the dV, what I'll write here, so my 10 log 10 to the power minus 4, that will be equal to minus 40 dV. So that is our source power. Therefore lambda is given as 0.85 micrometer. So what the first problem what they are asking you, so we have already seen in the fiber optics how many losses are there. So basically splicer losses is there, connector losses is there. So basically what I have to write here, so let me write all those terms which are given to us. So first of all I have to calculate the allowed loss that will be allowed for in the case of fiber optics. What are the allowed losses we can actually bear? So I can write here that will be power transmitted equal to source power minus received power, that is our allowed loss. So we have to calculate power transmitted, that is, so our source power we have already calculated, minus 40 dB is minus 40 and received power is 7.6. so what I am getting here is power transmitted is 36 dB. So if you have calculated the power transmitted, so now we can calculate the total loss. So how to calculate the total loss here? So I'll write here, therefore total loss is equal to attenuation loss plus connector loss. Since two connector are there, I have written here 2LC plus splicer loss, so NLSP, and after that safety margin. What are the safety margin which is given to us, that we will write. So for calculating the total loss, first of all I can write here that what is lambda, that is alpha s, that is attenuation loss. So I can write here attenuation loss. This is what connector loss. And what is this splicer loss. So whatever losses this fiber optics kit is experiencing, that losses we have to add. So any type of losses is there, we have to add all those losses then. So actually what we are doing, we are calculating the total loss. So for calculation of total loss, what we have to do, we have to add all those parity losses which we are getting. So what were our losses? That is attenuation loss, connector loss, and splicer loss. So separately we need to calculate all. So first of all we will calculate attenuation loss, then we will calculate connector loss, then splicer, then safety margin, and we needed to add all those things. So let me show you how to calculate. So what will be our attenuation loss? Attenuation loss will be lambda into L, that is 2.5 into 10, that is 25 dB. What will be our connector loss? For connector loss, I can write here for connector loss 2LC, that is 2 into 1.5, that is 3 dB. What will be our splicer loss? Splicer loss will be number of splices into loss of each splices. So what I can write, L by small l minus 1 into LSP. So I can write here 10 by 2 minus 1 into LSP. So I can write here 5 minus 1 into LSP, that is 4 into 0.3, that is 1.2 dB. So what I have calculated, that is our splicer loss. So that I have already told you how to calculate it. And what is the safety margin which is given to us? So safety margin is given as 6 dB. So how to calculate the total loss? So therefore total loss will be equal to addition of all those losses which we are experiencing. So that is 25 plus 3 plus 1.2 plus 6. So what we are getting here, 35.2 dB. So here we can say total loss is less than the allowed loss. So I have told you, so what I can say here, total loss is less than the allowed loss. So I have already told you one thing. So if and if only total loss will be less than allowed loss, then only the fiber optics kit will be good. Otherwise, it cannot be considerable. So first of all, we have to calculate the allowed loss, and then we have to calculate the total loss. And for calculation of total loss, we have to add all those small losses which the fiber optics kits are experiencing. That is attenuation loss, connector loss, splicer loss, and safety margin. So how to calculate the attenuation loss? So for calculation of the attenuation loss, what we have to do, we have to multiply alpha into length, whatever length which is given as. So in this problem, the length is given as 10 kilometer. So what I have given, alpha is given as 2.5. So I have just multiplied 2.5 into 10. What I'm getting here, 25 dB. And all those losses which we are getting here, we have to convert those losses into dB. So thus just remember this. And since I have told you, two connectors are fixed in a fiber optics. So one for the transmitting section and other for the receiving section. So whatever you are transmitting, that should be received Otherwise, there will be no why to send the signals, because if the signals are not getting received, so for that I have multiplied 2 into LC. So what is the value of LC here? That is 1.5. So I can write here 2 into 1.5 is that will be equal to 3 dB. So now that is how we can calculate the connector loss. Now moving on, how to calculate the splicer loss. So how many splices are there and what are the loss for each splices which we are experiencing. So first of all, we have to calculate how many splices are there. So if you can see, for calculation of number of splices, we can apply the formula L by small n minus 1. So that is the length upon how many connector loss 2. So 10 by 2 minus 1, so that will be 5 minus 1 equal to 4. So that will be our splicer loss. And what we have to do, we have to multiply all the losses of each splicer. So each splicer was experiencing 0.3 dB loss. So what I have done here, I have just multiplied 4 into 0.3. So what I was getting 1.2 dB. So that is how we can calculate the splicer loss. Now moving on, we have to see what loss we are getting for the safety margin. What are the values for the safety margin which are given in the problem? So basically safety margin was given as 6 dB. So that we have already written there. Now what we have to do, we have to calculate all those losses. So how to calculate all those losses? Whatever losses we have experienced, we have to add all those things. So I have added attenuation loss, connector loss, splicer loss, and safety margin. So 25 plus 3 plus 1.2 plus 6. So what I'm getting here, 35.2. So basically our allowed loss was 36 dB, and what was our total loss? That is 35.2 dB. So in this case, the total loss is less than the allowed loss. So if you are experiencing this, that the total loss is getting less than the allowed loss, then our fiber optics kit is working in a fine way. So this is all about the theoretical part which has been left to discuss. So is this clear to you? Is any doubt is there regarding this? Okay, fine. So this is all about today. Now, in the next session, we will see some of the experiments, which are one or two experiments which is left that we will see, and we will see some of the theoretical part on the fiber optics. So thank you everyone for joining this session. We will meet in the next class. Thank you.